Welcome to Chapter 13 of the Shapley Values series. In this chapter, we want to discuss how to interpret Shapley values and how not to interpret them. Let's dive right in. We have learned how Shapley values can theoretically be calculated and how they are approximated in reality. But how are they to be interpreted? Let's discuss some helpful guidelines for interpretation. Most importantly, one needs to always remember that Shapley values explain an individual prediction. For example, how a specific feature value, such as 20 degrees Celsius, affected the prediction for the sample of interest x. Explaining the individual prediction is also called local explainability. Furthermore, the Shapley value comes in the unit of the prediction. But what does that mean? Let's imagine in this example, we forecasted the demand in pieces for a specific product. Then a Shapley value of 4.5 for the temperature value of 20 degrees Celsius states that the demand for that product increased by 4.5 pieces compared to the average demand. Next, since Shapley values explain feature values for an individual prediction, they don't provide information on how important a specific feature is overall. That means a Shapley value for temperature in this example only tells us how important 20 degrees Celsius are for the prediction of sample X, but not how important temperature as a feature is overall for predictions for all other products. Next, it's important to understand that Shapley values don't express how much the prediction would change if the feature value changed. That means the Shapley value of 4.5 for the temperature of 20 degrees Celsius does not tell us that the increase in demand would be 9 pieces if we doubled the temperature to 40 degrees. Simply said, Shapley values should be interpreted as such. The value, for example 20 degrees Celsius, of feature J, for example temperature, contributed Y, for example 4.5 units, to the specific prediction X, for example the item A in location B on day 2, compared to the average prediction, for example 0. So as a general guideline, Shapley values should be used to understand an individual prediction and not general or global feature importance. However, there are some ways to look at Shapley values on an aggregated level over many different predictions, which can provide some interpretation that is closer to general feature importance, that is, global explainability. We will look at such aggregations in a later session. To strengthen our understanding, let's look at examples of correct and incorrect interpretations of Shapley values. First, let's look at this statement. For the prediction of item A in location B in week 1, the value of €5 for the feature price increased the forecast by plus 600. This is the highest Shapley value for any feature for this specific prediction, hence the price feature had the biggest effect for this prediction. This statement is correct, as it acknowledges that the Shapley value of plus 600 for price is the highest Shapley value and therefore the most relevant influence for the respective prediction example. Next, let's consider the following statement. For the prediction of item A in location B in week 1, I can see that price has the highest Shapley value. That means that the feature price is the most important feature in general. This statement represents an incorrect interpretation of Shapley values. Because it claims that the Shapley value for a price for the specific prediction example is representative of all predictions and thus making price the most important feature. We have to remember that unaggregated Shapley values offer only local explainability. That is, they don't tell us which feature is most relevant overall, but only which feature value is most relevant for the prediction of interest. Let's look at this third statement. The Shapley value for price is plus 600 for the prediction of item A in location B in week 1. That means if I double the price, the effect of the price feature will double to 1200. This statement is also incorrect because Shapley values do not express causal relationships and can therefore not be used to infer what a change to the feature value would mean to the prediction outcome. Lastly, let's consider this statement. I have calculated Shapley values for many locations for my item A in week 1 and can see on an aggregated level that the effect for the feature price is the highest out of all the effects. That means that the feature price is the highest influence on my forecast for item A in many locations for this week. In contrast to statement 2, which aims at deriving general feature importance from a single prediction example, this statement applies the correct logic of deriving general feature importance by aggregating the Shapley values over many prediction examples. Due to the additivity property of Shapley values, such a statement can be made when correctly aggregating Shapley values over a big enough sample size. Again, we will see examples of this in a later session. So, let's summarize the philosophy behind the interpretation of Shapley values. When interpreting Shapley values, remember that they answer the question of why a prediction turned out to be this way. They do not answer questions about causality and consequently don't answer questions such as, what if I changed my price? How can I increase the prediction? A wise data scientist I worked with once summarized the philosophy on interpreting Shapley values with the following quote: "The sun is the cause of life on Earth. That doesn't mean that two suns will lead to more life on Earth." To conclude this session, let's look at an example prediction and its Shapley values. For this, we will look at a so-called waterfall plot that was created with the Shap Python library. It displays the Shapley values for a prediction example for a house pricing prediction based on a model consisting of the feature values for median income, latitude, longitude, house age, average number of rooms, population in the area, average number of bedrooms, and the average number of household members. The waterfall plot visualizes the Shapley values by displaying the average prediction, here 2.215, the prediction for the sample of interest, here 2.846, and the Shapley values for the corresponding feature values. The median income of 6.232, for example, contributed plus 0.92, and the longitude of negative 118.03 contributed minus 0.52 on top of the average prediction. The sum of all these features Shapley values added to the average prediction equal to the predicted housing price for the prediction example. This visual example displays the additive property of Shapley values. Note that the predicted housing price, as well as all of the Shapley values, are here given as the natural logarithm of the median home price, rather than in actual US dollars. This fact illustrates that Shapley values are always calculated in the unit of the prediction, which can be US dollars, the natural logarithm of US dollars, or any unit you might want to forecast in. Also note that the average prediction is derived from the background data, that is, the input data that was given to the Shap library when calculating the Shapley values for the prediction example. Consequently, the background data should be representative of the population for which you want to interpret the model's prediction. In this session, we have seen some useful guidelines on how to interpret Shapley values. Now it's time for you to apply this technique to your prediction task and explain your model's forecast to yourself and to others.